Hello friends, welcome to my channel. In this lecture, we will understand the concept of full wave rectifier. This is the second type of rectifier we have discussing. In the previous lecture, we have discussed about off wave rectifier and we understood the efficiency of the off wave rectifier, ripple factor and as well as the peak inverse voltage. Today we will start with full wave rectifier. This full wave rectifier rectifies the complete waveform. It rectifies complete waveform and also a AC signal. See here, this is an AC signal of full wave rectifier, which means it rectifies both positive off of the input cycle and negative off of the input cycle. Positive off of the input cycle and negative off of the input cycle. That's why they name full wave rectifier. This is a circuit of full wave rectifier. As you can see, the full wave rectifier circuit consists of a transformer, a two diodes and a load resistor. See here, this is a load resistor. The secondary off of the transformer, there are three terminals. We are considering all these three terminals. So this rectifier, because the secondary off of the transformer, we have two sections. These are the two sections. You can see this is the upper section from this point to this point, and this is the lower section from this point to this point. The same voltage will see here, whatever voltage appear across the upper section, the same voltage will appear across the lower section. That's why the name is center tap. Now let us see the working of a full wave rectifier. To understand the working of a full wave rectifier, we will consider an AC signal. Let us see here, this is an AC signal which is V2. We are considered here which is V2. The input to the rectifier, which is V2, the input to the rectifier. V1 is a AC. V1 is a AC supply, AC power supply, which will be 230 volts and 50 hertz. 230 volts and 50 hertz. Now V2 is having both positive off of the input cycle as well as the negative off of the input cycle. See here, V2 will have positive off of the input cycle and the negative off of the input cycle. Positive off of the input cycle and negative off of the input cycle. So from the definition of full wave rectifier, that it will rectifies both positive as well as the negative of the input cycle. So if we consider one positive and a one negative, that it is one complete waveform. That's why the name is a full wave rectifier. Now we will see the working of a full wave rectifier. So working of a full wave rectifier will understand by taking a two cases. Again, so in first case, the during positive and a negative. See here, by taking two cases again. So first case, the during positive off of the input cycle, what will be the behavior of the circuit, and during negative off of the input cycle, and what will be the behavior of the circuit. First, let us consider during positive off of the input cycle. The polarity across the upper section of the secondary of the transformer will be positive and a negative. You can see V2 will be positive and a negative during the forward bias condition, and since the same voltage will appear across the lower section of the secondary of the transformer, the polarity here, it will be positive and a negative. In this lower section also a positive and a negative itself. Now from these polarities we can understand that the diode D1 is a forward bias because anode is connected to positive and cathode is connected to negative terminal. And diode D2 is reverse bias because anode is connected to negative and cathode is connected to positive polarity. Now we can write D1 is a forward bias in positive half of the input cycle. See here in the graph we can see here D1 is a, see here, positive half of the input cycle. Here D1 is a forward bias condition for D1. And see here, now let us see here, D1 will conduct in forward bias condition, so current will flow in the circuit and it will passes through the load resistance and it will get the output voltage due to the forward bias condition of for D. So we will see in graph, we will get a output voltage in the positive half of the cycle. Positive half of the cycle will get a output voltage. During negative half of the input cycle, the polarity across V2 will be negative. The same polarity will appear across the V2. See here, which of the secondary of the transformer? And now next let us see, the same polarity will appear across the V2, which is the lower section of the secondary of the transformer. It will be negative and positive and positive. Due to these polarities we can observe that D1 is reverse bias. Because negative is connected to anode and positive is connected to cathode. And D2 is forward bias. D2 is forward bias because positive is connected to anode and negative is connected to cathode. So we can say D1 is reverse bias during negative half of the input cycle. First let us now next see during positive half of the input cycle, D1 is a forward bias and D2 is a reverse bias, and we will get a voltage V0. And during negative half of the input cycle, D1 is a reverse bias and D2 is a forward bias. See here, D1 is a, when the positive half of the input cycle, we will get a D1 is a forward bias and D2 will be a reverse bias. And in negative half of the input cycle we will get a D2 is a forward bias and D1 is a reverse bias and D2 is a forward bias, and it will be continue same. So we can say D1 is reverse bias during negative half of the input cycle and D2 is a forward bias. Since D2 is forward bias, and we will get the output voltage is a V0 due to the condition the conduction of diode D2. See here in this graph, hence we will get output voltage during positive half of the input cycle due to D1, and during negative half of the input cycle we will get the output voltage due to D2. The same process will continue. Okay, during this positive half will get the D1 and negative half will get the D2, and during negative half will get the output voltage due to D2. See here the evolution of V1, V2 and I remains same as we have discussed for the off wave rectifier in a off wave rectifier. Now let us see. Now we will discuss about the characteristics of full wave rectifier. Full wave rectifier. The first important characteristics is the efficiency. So we can define efficiency, which means while discussing the characteristics of off wave rectifier, efficiency is the ratio of output power. The efficiency of output, the ratio is output power, means here efficiency equal to output power divided by input power equal to 81.2%. 81.2%. The efficiency of a full wave rectifier. And now next second characteristics is the ripple factor. The ripple factor of full wave rectifier are equal to 0.482, which means for each DC component, for one DC component there will be 0.482 AC component, which is very less compared to the off wave rectifier. And the next one is the third characteristic is PIV, means peak inverse voltage. We know that this is a peak inverse voltage can be defined as the maximum reverse voltage that can appear across the diode when the diode is connected in reverse bias condition. During positive off of the input cycle, diode D1 was conducting and D2 was reverse bias, and during negative off of the input cycle, diode D2 was conducting and D1 was reverse bias. So the maximum voltage across D2 during positive off will be Vm, and the maximum voltage across D1 negative off of the input cycle will be Vm. So we can add this 2 Vm equal to 2 Vm, we'll get a 2 Vm. So the peak inverse voltage of full wave rectifier is Vm plus Vm, which will be 2 Vm. This will be peak inverse voltage. There is most popular question that will be as why full wave rectifier is preferred over the off wave rectifier. If we write differences between off wave rectifier and a full wave rectifier, so we can identify that the efficiency of a off wave rectifier is 40.6% and the full wave rectifier is 81.2%, and also the ripple factor is R equal to 1.21, and then full wave rectifier 0.48. So these two are the very important factors. You can see the full wave rectifier is very high efficiency compared to the off wave rectifier, as well as it is having low ripple factor compared to off wave rectifier, low ripple factor compared to off wave rectifier. So because of these two factors, we'll consider full wave rectifier over a off wave rectifier. Hope you have understood of this topic. Thank you, and please do subscribe.